Well, an Indianapolis researcher will have her experiment performed in space. Her work will blast off with the next space station in June. Barbara Lewis has more in the business of health. Barb.
Gary, thank you very much. Well, this experiment will test various bone healing therapies, and the space station is the perfect environment. No gravity means no ability to put weight on bones, and weight is what keeps them strong. So joining me to talk about the space station research is Melissa Cassina, Associate Professor of Orthopedic Surgery at the IU School of Medicine, and this is exciting.
It is. Thank you for having me too.
So tell me first how you were chosen to have this experiment done on the space station.
Well, that's kind of an interesting question. So my background is actually in aerospace engineering. That's what my PhD is in. And then I kind of moved away from the aerospace engineering and really started looking at the life sciences. So I developed spaceflight hardware for biologic application and was looking at how bone cells grow in spaceflight. So then I did a postdoc in orthopedics, and then I came as a faculty member about 9 years ago to Indiana in orthopedics. And I was at a DoD conference because now the focus of my work is on bone healing, and they were very interested in its applications to our military personnel that have blast injuries. And fortunately, I ran into the right person at the right time, and they were very excited to have me start leading their bone healing in space program.
So is this experiment then for the Department of Defense?
It is.
All
That's
right.
the primary sponsor,
Okay.
in addition to NASA and CASIS, which is the Center for Advancement of Sciences in Space, to help us utilize the space station.
Okay, so what is the experiment?
So the experiment is to look at bone healing in space, and we're looking at use of what the orthopedic surgeons currently use in the clinic, as well as our novel bone healing protein.
Okay, and so will you be working closely with the astronauts then? I mean, how will your...
Well, so the astronauts will be our hands in space.
Okay.
We'll do the surgeries down on Earth at Kennedy Space Center 3 days before the launch, and then all the healing will progress in space. But the astronauts will take care of our mouse astronauts while they're there, and I'll be helping train the astronauts. So far, we've already worked with the astronaut trainers to tell them about different techniques and things to think about, and then hopefully I'll be going down to Houston to help train them at Johnson Space Center.
Okay, and then so how long do you have to wait? I'm just wondering how often you'll get updates and when you'll actually be able to find some results out.
Well, I have conference calls with NASA almost daily now, and we meet on a very regular basis, and we'll get the samples back about 30 days after they're launched, and then it's just up to us. We'll look at bone healing progression. We're going to be doing a whole omics screen, so genetics, protein analysis, a whole bunch of biological analysis to try to associate bone healing progression, and that should just take a few months after we get the samples returned.
And it seems like a short amount of time to do an experiment, but there you are, they are in space. I mean, you really have this wonderful, unique environment. Will you be able to have some really good conclusions, do you think?
Oh, we definitely will. So this will be the longest the bone healing's actually been done in space. It's only been 5 days or 14 days. So if we go out to 30 days, it'll be much longer than what we've already done. And we've optimized the model so that we can learn as much as we can in this short period of time.
Okay, so you have the astronauts are doing your work for you, but I'm guessing that in the space station it won't be quite as easy as what you can do, you know, just a few miles from here.
No, it's very complicated, and that's something I've learned is, you know, the astronauts, they're great at certain things, but they need to learn how to run hundreds of different experiments, engineering, biology, the whole gamut. And so we can train them a little bit, and they only have 6.5 hours to work a day, so that's a nice schedule. And we need to plan things very differently. So something that would take us maybe 10 minutes on Earth, it'll take them about an hour and a half. So we really need to try to figure out easy ways to help them do this. In fact, they get something that's called like brain fog. It's almost, you know, you just kind of are out of it a little bit, so you need to make things easy and color-coded and, you know, remind them how to do things. So it's been an interesting learning experience.
Well, we're interested in hearing the results. Melissa, thank you so much.
Thank you very much for having me.
Gary, back to you.